What up, nerds? In this video, I'm going to be covering getting started with C Sharp inside of Godot. I'm not going to be covering cross-language scripting in this video. However, I will cover how you can translate GScript into C Sharp. If you do like this video and you want to support the channel, check the description below. Now, the project that we're going to be building is the classic rollerball project because it does touch on a good amount of core game dev principles, so we can see how we approach problems in C Sharp. When you create a new project in the C Sharp version of Godot, you actually don't have a C Sharp solution, so we need to go ahead and make one real quick. To do that, we go up to Project, Tools, C Sharp, Create C Sharp Solution, and I've already done that myself. It's a pretty quick process. The only other difference between what I have now and what you might have is I do have my sound file already imported, and you can find a link to downloading that in the description below. So we're going to go ahead and start off by creating a 3D scene. I'm going to use a node 3D, rename it to world, and then we're going to add a mesh instance 3D. This is going to be the ground. Then we're going to add a rigid body. This is going to be the player. Oh, we want to add a mesh instance 3D to represent the player in the world, and then we need a collision shape as well. Other things that we're going to need is a camera 3D, and that's actually it for right now. We'll add the other stuff later, so let's get everything set up. We'll go ahead and add the sphere shape because it is supposed to be a ball. Add a sphere mesh. Where is it? Down here. And the player is more or less set up. For the ground, we're going to use a simple plane mesh. And let's go ahead and bump the size of that up. And for the camera, what we're actually going to do is go up here to the top of the viewport, change it to two viewports, have the bottom one actually look at it through the eyes of the camera, and then we're going to adjust it to however you actually want. I want to see the entire map, well, the entire level myself, so I'll get it to be in view, and that's all we really need. So go ahead and bring it back to one viewport. Let's go ahead and move the player up a little bit. For the ground, if we start the game right now, we won't have any collisions. So a quick way for prototyping purposes is to come up to this mesh button and click try mesh static body. It's going to create this static body and collision shape for us. It's not the most performant, but it's fine for prototyping purposes. So now, the last things we need to add in order to actually see in the world is a sun and an environment. So then from here, we can go ahead and save the scene. I'm going to rename it to have a capital W. And then if we go ahead and press F6 to play, we can see everything. Perfect. So now let's go ahead and give some functionality to the player. Go ahead and add a script. Make sure you change it to C Sharp at the top, and we'll go ahead and hit create. We're actually not gonna use the built-in script editor for C Sharp because it doesn't really have support for it. You can use either Visual Studio Code, Visual Studio, or Writer, or any editor that actually supports C Sharp. I prefer Writer myself, so that's what I'm going to be using. Now, we also don't need any of this because we are using a physics body, so we definitely don't need process. Now, in GScript, you might be used to exporting things to the inspector by doing this @ sign and then export. For C Sharp, we're going to be using attributes, so we're going to do export like so, and then public float speed, and make this an auto property, and there we go. Now the other thing that we want to go ahead and override is physics process. Now, oh, it didn't actually do it. Oh wait, it did. It's just not actually in use. It's not different from the parent method, so there's no need to override right now. So something else that we want to do that I actually did already do is go up here into project settings and go into the input map and set up your input mappings. All you do is add the new action here, and when you add it, you click the plus button, press button, and then select it. I've already set mine up. You can name him whatever you like. Now, something else that I actually like to do is to create a C# class to actually hold all of the input mappings. And to do that, I'm going to go ahead and create it. We can just call it input mappings. Then we'll make this a static class. And then from there, what we want to do is public static string name. And we can call this move up. And then this is going to just return move up. Now, this will automatically convert to a string name for us, so we don't actually need to do that whole new string name. So go ahead and type it again, just for muscle memory. Move down, but realistically, I'm just going to duplicate it. So move left, move right, and then fix that up. And the reason I like doing this is to have a more easy way to actually rename the mappings if I need to, or refactoring the actual variable names. And you'll see how we can more easily reference the same string name. So in here, the first thing we want to do is actually set up the velocity. So we'll do var velocity equals input dot get vector, which returns a vector 2, and as we can see in the description, it wants the negative x and then the positive y, and this is where the mappings come in handy. So the negative x is going to be move left, the positive x is going to be the move right, and then it also wants the negative y and the positive y, so that's going to be input mappings dot move up, because remember we are in 3D, and in 3D negative z is forward, so we're going to be using the y as forward and backward. So when we actually want to move forward, that's actually our negative value. So then we'll go ahead, no, not input mappings, and then this one is moved down. Okay, so now we have our velocity. So what we want to do is take our velocity, multiply it by our speed times, we're going to cast this down to a float by our delta. The reason we need to cast it is because velocity is a vector of floats. So if we actually don't have this, it will complain. And here, so you can see it complains. So we'll just cast it. And then to actually get our rigid body moving, we can apply impulse, new vector 3. So for our x, we actually want to use our velocity's x. Our y, we have nothing to do with elevation. And then for our z, we want to use our y. All right. And now, if we come in here, you'll notice we don't see anything up here yet. We want to build the project, and then there we go. So now, if I save it, you can see that I'm moving around. All right, so let's see here. Actually, let's make sure my input mappings are right, because I noticed that I wasn't moving left or right. What did I do wrong here? I'm going to pause the video and figure that out real quick. All right, I went ahead and figured it out. While I was duplicating, I did forget to fix this. So now everything is fine and dandy. And as you can see, we can move around. All right, so now we have our player moving around. We have input entered in. And by the way, I also did change the speed. You can set it to whatever you like. So now what we want to do is add in some safety. So let's create some walls. That way we don't actually run off the map. So all I'm going to do is get this in place. I'm going to go ahead and extend this along the X. Let's do 20, because that should be good. And then we can Control D and move that across. And then Control D again, move that across. Hold Control to have it snap properly. It doesn't have to be perfect. All right, so then all we're gonna do is the same thing as before, just run through and make sure all of these have collision. All right, that way we don't run off the map. All right, so now next thing we need to do is actually create a coin. So what we can do is, let's see, create a simple mesh. We can call this coin, and for this we want an area 3D actually, because we don't really want it to collide per se. We want it to actually just overlap. So we'll go ahead and add that. The coin, we'll go ahead and make it a box, and then we'll give the collision shape a box as well. And let's go ahead and color this box. So in order to do that, we'll go to the surface material override, go in here, we can create a new standard material, and then we'll go down into the albedo and we'll make it a yellow color. All right, so now we'll go ahead and add a script to this as well. All right, so for this, we actually do want the ready function. Now, what we want to do is bind to this, where is it? Body entered signal. I'm going to show how to do it through code. So we do go. I'm so used to using the built-in editor. We'll bring up our IDE and we'll do get node, and this is going to be of type area 3D, and then this is going to be the actual node path. So because this is a direct child, it'll just be that, and then we're going to go ahead and bind to the body entered event. In order to do that, we'll go ahead and do plus equal, and then I'm going to go ahead and just create the onBody entered function with my help of the IDE, go ahead and remove the unnecessary process for the time being. We will be using it later. It's just clutter right now. So let's go ahead and write some code that we actually want to happen when the body is entered. We just want to queue free it for right now. That's it. Now, there is an issue with some of the signal handlings in the C# side of Godot. So as a precaution, what I do is just always unsubscribe myself, because there are some situations where you don't need to. So, but honestly, sometimes I forget them, so I just unsubscribe. It's easiest for me. Realistically, this may not even be needed because the Area 3D is going to be freed when we do queue free the coin, because do remember the coin is the parent of the Area 3D, so it'll probably be fine in this case, but it's still something I do want you to be aware of. Now, with this done, let's go ahead and go into here. Actually, because we're going to want multiple of these, what I'm going to do is right click on the coin. I'm going to save this as a scene. All right, that way we can just throw these everywhere we want. Go ahead and duplicate. So let's go ahead and run the project, make sure everything works. And we can collect them. So let's make these a bit more interesting. And that's where the process function is going to come in. So let's go ahead and override that. And in here, all we're going to do is rotate around the Y. And let's see, we want to do degrees to, oh no, not that one. That's the one that I meant. We're going to do degrees to radians. And what we're going to do is give this a float. So let's do 3.0 F. That should be fine. But we don't want to always come in here to actually change that. So we'll make this an export public. Oh, I don't know why I made it capital float. Let's just give it the name rotation rate. And then go make it like so. And then we'll just give it rotation rate. So now, remember, we do have to build. Now we have it here. And when we actually play it, it gives it a little bit more life. Now that we have these, now that we can collect them, what we want to do is play a noise. So to do that, we go ahead and add an audio stream player. And what we want to do with this is give it the pickup noise. And by default, the volume dB is a bit loud. So let's bring it down to like about -8, -16, -12, whatever you really want. But this is a decent noise level from my experience. So now with this, we want to play this when we actually collect it. So what we want to do is get a reference to it, get node audio stream player, audio stream player. Oh, I forgot my other angle bracket. Go and fix that up. And then we will go ahead and bind to the finished to be cue free. And then we're going to play. We're going to go ahead and play that sound. That way it will delete the coin when we actually finish playing the sound. So we can go ahead and play. But as you can see, it stays around for a little bit. So let's go ahead and quickly fix that. All we need to do is throw down hide. And now, I hit F5, which if you haven't, you can go ahead and do that as well. And now it looks like it is collected immediately. But there's still an issue. Let's go ahead and show that issue. We'll do gd.print collected. All right. And this will print it to the console. So if we run this again, it's going it's a little hard to do, but it's not completely freed yet. So it was really hard to show because the ball was moving too fast, but because it's not actually destroyed, we can enter that body multiple times. So we can just set up a very simple bool is collectible, and that can be false. We can actually make this public just in case in the future we want to do something else. Check, maybe do things, maybe check if sorry, brain's kind of losing myself right here. I'm trying to fix these errors. There we go. But we can make it public. That way, in case we want to have some logic later on that can check if the coin is collectible, do something else. So what we want to do here is, if it is not collectible, we can just return. Otherwise, we'll go ahead and set it to false. They should start out being true, and this should be pretty much most of everything that we want to do with this. So now we have a way to roll around, we have a way to actually collect the coins, but what we don't have is a way to display the score. So very simply, we can add a label, just call it score, and it doesn't really need a text, but we can give it a script, and from there we'll go back into our IDE, open score, and let's go private. We actually don't want this to store any information. We just want it to display information. So we'll go ahead and go. Actually, no. It's fine to actually keep the score in here. Or you know what? No. That's putting too much data in here. So we can just do score that, And then what we want to do is have some way to tell some score tracker that the coin is collected. Now, me personally, what I'm going to do is I'm going to use a native C# event. All right. The more Godot approach would be to use, say, an autoload or a script on the world, but I want to show you how we can also use native C# features to do our game. So what I'm going to do is create a new class, and I'll just call it Score Manager. Maybe not the best name, but it's very specific. But for the purposes of our little project, it's good enough. So what I'm also going to do is make it a static, because all it's going to do is invoke an event, really. So we'll do public static event handler, and what we're going to do here is pass in coin, and we'll just say coin collected. Now all I did was use Writer's auto import feature. So to actually use the event handler, it's in system. So when we come down here, we can do public static void, and I don't like calling these coin collected. I'm going to call it notify coin collected. And then what we want is the coin. And all we're going to do is coin collected. And we can pass in null, but it's generally good practice to actually tell the instance of what the object is, but in this case I don't really care. All right, so now what we can actually do is go back to the coin, and in here all we need to do is get the score manager and notify what was actually notify that something was collected, and then we'll go ahead and go into score. All right, we'll go back to the score script, and then we'll go to score manager on coin collected, and then we can do sender. You know what, I'm just gonna use that, and then there we go. No, sometimes it just does this, so we can do text equals score, and we can do current score. So turns out that we will end up needing this, so I'll just let it autocomplete. And yeah, this should that's my own little custom setting. We can ignore that. This is standard C# convention. And what we want to do when we actually collect it is do current score. We don't want to increase the value. We just want to increase it by 1. And then, of course, when we exit tree, we're just going to actually, we don't even need this, because when we're exiting the tree, the game's shutting down. So now when we play, oh, you can see in the top left, we have the score showing. So let's go ahead and just do that. And there we go. We have more or less the basis of a very simple game. We can go ahead and duplicate this, duplicate that, duplicate it again, however many times as you want. And you can fly around, collect the coins, and yeah. So this was just a quick primer on getting comfortable with C# inside of Godot. And there were some areas where I stumbled, a bunch of brain stumbles, but it happens, and that's okay. Now, one last part that I do want to cover is there's not a lot of tutorials out there about C#, so I want to cover real quick how we can actually translate something from GDScript to C#. Now, in general, a lot of the attributes that you're going to see, they're going to, from GDScript, they're also going to have an equivalent attribute for C#. Okay? And if you notice, a lot of the lifecycle methods like process, ready, physics process, etc., they're going to be in Pascal case with an underscore in front of it, just like the GDScript variant. And then pretty much every method that you'll find in the documentation, let's just say go to search help, we can do rigid body. We'll look at the rigid body 3D. And we'll close this. And then let's scroll down to the methods. If we look down here, we have like gravity scale, freeze mode, freeze, etc., etc. Now, if we go back in here, we can do gravity scale. This is going to be a property. Oh, well, yeah, that's because I was looking at the properties, not methods. But the properties are going to be in Pascal case as well, because that's what C#'s conventions are. So if we come down here and actually look at the methods this time, really, you can see apply impulse, apply force, apply impulse is right here. So in general, what you can do is convert what you see in GDScript into C# convention, and that is more than likely going to be the actual answer on what the API is for C#. Now, there are some other caveats, which I will cover in other videos, but if you did enjoy this video, if it did help you out, if you want to see more C# things, please let me know in the comments below. And again, if you did enjoy it and you want to support the channel, you can look in the description below and see how. All right, see you nerds.